The SUNY College of Environmental Science and Forestry, founded in 1911, is now the only institution of higher learning in the United States dedicated solely to the study of natural resources and the environment.
Hello and welcome to this edition of Improve Your World with SUNY-ESF. I'm your host, Don Torrance, and today we're coming to you from Baker Laboratory on the SUNY-ESF campus, and we're surrounded by the very topic of our program today, wood. We'll get to the specifics of that in a moment, but we're not just talking about trees and 2x4s. As we move toward a more environmentally responsible society, the efficient use of wood and emerging green construction practices are becoming more and more important. We'll talk more about green construction a little later on in the program, but first we want to get to the very basic elements of the show. What exactly is wood?
Wood is a far more complicated substance than we all think. But using the scanning electron microscope, SUNY-ESF professor Bob Hanna can take us right inside the wood to see what it's really made of. The microscope allows Dr. Hanna to look at the structure of the wood at the molecular level.
One cell in the scanning electron microscope, this is in the late wood, it consists of cellulose microfibrils, which are small crystalline fibers of cellulose, and they have different orientations within the cell. Now, people think of wood as a solid material, but it's actually similar to a bunch of hollow straws that are glued together. And the straws are really cellulose and hemicellulose with a little lignin, and the straws are glued together with lignin. And if you look at the rings of the tree are composed of early wood. Those are the cells that are synthesized early in the year, and they're very large cells with very thin cell walls. Then later in the summer, we form the late wood, which are dense wood cells with a thick cell wall, and they're smaller with a smaller lumen.
By simply turning the wood sample on its side, the microscope shows structures called bordered pits that regulate the flow of water between the wood cells.
And you can see that there are many of these bordered pits on the radial surface of the fibers. Why are different species used for different uses? And it relates to strength, the cell wall, and actually the structure of the cellulose. How the cellulose is actually oriented within the cells.
Stacy Lang reporting for Improve Your World with SUNY-ESF.
When thinking about green construction, it's important to know what kinds of wood are available. There are all different kinds. Some are more suitable to some tasks than others. So we consulted an expert, Dr. Bob Meyer, about the various kinds of wood and what works for whatever it is you're trying to accomplish.
What wood for what is a function of really what kind of a tree you have. We have so many kinds of trees in North America that are used commercially. There's about 80 trees that we do use commercially, about 30 softwoods and about 50 hardwoods. Here we have a display to demonstrate some of those types of wood. We start out on this end of the display where we can see some dark portion of the tree that is the heartwood. The wood on the outside of the tree is sapwood. So that if we take a look at a disc cut from a tree, we can see that the wood near the center of the tree is dark in color, and that we'd like to use that for certain uses. And the wood on the outside of the tree is light in color. The color difference is because of the chemicals in the wood, and the chemicals in the wood will make the wood very durable or less durable. The heartwood has the properties that we like. The sapwood has properties that are not there for durability, although it is still very strong. So here on this wall, we can see the various types of wood that are present. When trees are growing, they have branches in them. In the case of softwoods, which we use for structural purposes, when there's a branch present and we cut a section through the branch, we produce a knot. In this case, this is cut lengthwise through the branch, and the knot takes up a large percentage of the wood and makes the wood relatively weak. If we would cut this at a right angle, we would have a round knot, where now we have cut a cross-section through the branch, and we have a round knot, so it takes up a less percentage of the strength. So in our softwood trees, we always have knots present because we use them structurally and we use the whole tree. When we get to the hardwoods, we don't like to have any knots present because when we make furniture, we don't like to have any knots. So when we get a wood like cherry that we like to use for furniture, We have that heartwood on the inside with that nice color that we enjoy so much. But on the outside of the tree, we have a lighter colored wood, and we prefer not to use that for our furniture. Therefore, we always use the heartwood of a tree like cherry, and we get that beautiful color that we enjoy so much. When we get to other woods, like say this piece of hard maple, it has an odd grain that we call a bird's eye effect. In this case, the grain has little swirls in it that are very beautiful. And so we get the bird's eye effect. This is very hard to produce in a tree, but it makes the wood very attractive, and you could use that for furniture uses. Next to the piece of maple, I have a piece of birch here, and we see the appearance of the grain of the tree. It gives a very much of a three-dimensional effect to it. Very beautiful wood because of the grain orientation of the wood. And it's a matter of how the cells were growing, and as the cells were growing, then we had the chance to reflect the light differently towards you. This is a piece of mahogany. As this mahogany tree was growing, for a few years the cells were oriented in one direction in the tree, and then for a few years they were oriented in another direction. So as I move this around, you can see how it reflects the light. The reason it does that is that as the wood was growing, the cells were oriented in different directions, and by being oriented in different directions, we have some of the cells lined up parallel to the surface and some cells at an angle to the surface. Therefore, they reflect the light directly towards you when they're parallel, and they absorb the light when they're at an angle to the surface. So this makes for a very beautiful piece of wood. And then in order to produce a product from it, this is a thin piece of wood called a veneer, and in this case we have that same effect that we had on the mahogany, but this piece of wood is cut very, very thin so it can be glued onto another substrate like a solid piece of wood or even particle board. And although it's very thin, we can get a large surface area to produce a lot of furniture from it. And so we get this very beautiful appearance. This wood is sliced very, very thin in order to maximize the appearance and have a chance to get as much product as possible. So we wind up with a chance to make some very beautiful furniture that anybody can afford. Here we have a display that shows some of the popular woods that we use in this country. This piece of black walnut, for example, we enjoy because of that rich color that it has, and it's a very highly desired wood for making our furniture. There are some other woods that we have in this country that do not come in a big enough form in trees, so we do not use them for products. Today we are growing trees and harvesting at a much younger age, so they're not as large as we would like them to be. This piece of Douglas fir, for example, is not big enough to produce a very large product. This piece of glued laminated beam, it was manufactured from southern pine. It was made from a large number of trees that in themselves were not terribly large. So we can still get a large product from a small tree. There are about 10 or 20 species of oak growing in North America. They are all very much different. We divide them up into two main groups, the white oaks and the red oaks. And here on this section of the wall, we have representative of some of those wood species. The red oaks are used more for furniture, and the white oaks are used where we need durability and strength, as, for example, in railroad ties. Another way to get a very large product from a smaller tree would be to cut veneer from the tree and then glue it together. This is a piece of plywood. It is manufactured from a large number of plies that are here glued together. 1, 2, 3, 4. This is manufactured from 5 pieces of veneer that have been glued together in order to make the final product. And after gluing it together, we get a product that is very strong. The cells are oriented so they are growing in one direction on the face and the opposite direction on the plies that are on the inside of the piece of wood. And then on the opposite face, the grain of the wood is again running in the same direction. On the back side of this piece of plywood, you can see some knots present. This would be a lower grade of plywood that you would put, for example, on the inside of furniture or someplace where you did not need to see it. On the back side, or the front side of the plywood, there are no knots present. This is a higher quality of wood because there are no knots present. This is an example where we make large pieces of wood from very small trees. As we look at this piece of wood, we see that there is a knot in it, and we see that the growth rings that surrounded the knot are all moving out in various directions. When the growth rings hit the surface of the piece of wood, they are at an angle to the surface. That is going to have a dramatic impact on the strength of the wood.
One of the two most commonly used tools is a screwdriver. Screwdrivers are made to drive specific types and sizes of screws. This is the flathead screwdriver. The flat blade varies in size, which is selected based on the size of the screw slot. The closer the match, the easier it is to tighten the screw. The Phillips head screwdriver is designed to be used with screws with an X-shaped slot. Again, the closer the match, the easier it is to tighten the screw. Which screw to use? The Phillips head screw is designed for the application of extra torque, so it provides a tighter fit. Use it when tightness is critical. The Allen key or Allen wrench, a hexagon-shaped screwdriver, is often used to put together furniture. It's often L-shaped. Power screwdrivers come in two forms. One is a socket driver approach that can be used with power drills. Many drills have special speed settings for driving screws. The second is a standalone cordless electric or power screwdriver.
I'm joined now by Dr. Bill Smith, who's a professor in the ESF Department of Wood Products Engineering. Thanks for joining us, Bill.
Glad to.
I want to talk about the role of wood. There's some controversy, or at least some confusion on the part of some people when we're talking about building with wood and trying to be environmentally friendly. I think a lot of people envision us clearing forests, especially old growth forests, or taking exotic trees out of rainforests and the like, but there are a lot of wood products out there. How versatile and how environmentally friendly are a lot of the products that we can deal with today?
They're extremely versatile and quite environmentally friendly. When you look at products from the forest, in particular wood products, for the time being, let's say, not speaking of paper or fuel directly, but we have things that kind of look like a tree, a utility pole, or put the utility pole in the ground and call it a piling for foundations, for buildings, large structures. Railroad ties that run products back and forth across the country much more efficiently by rail than, say, trucks. Furniture in our homes, cherry, oak, maple, very fine hardwoods that many of us like for our floors, dining room, bedroom, living room furniture, kitchen cabinets. The framing in our homes, offices, businesses, could be spruce, could be pine, could be Douglas fir, could be hemlock, could be balsam fir, depending upon where in the country you are and where it's been sold. And then, of course, the engineered products, sheathing, plywood, oriented strand board that go over our roofs, our floors, and walls of our structures. And then the engineered products that we can use to make into large timbers that would replace some of the large trees that are either not available or we choose to not make them available from preserved forest.
Now, many of these are from forests that are cultured for these exact ends, is that correct?
Many, but in particularly when we think of cultured forests, more typically plantations, this would be primarily pines down south.
Faster growing.
Right, and they're really maintained as a crop.
Right.
Again, in Canada, Maine, spruces, out west, hemlocks, Douglas firs, but the hardwoods that we think of in New York State in particular really aren't in plantation forests. They're naturally grown forests.
Okay. We have a couple of examples here we just want to have some fun with. We talk about trees being able to take up carbon and hold them, as sort of carbon sequestration, I guess is the term. And one example of that might be this, your favorite bat. Can you tell us why that's the case? And this is a perfectly environmentally friendly product.
This was a bat that was made for me personally, not because I'm a famous baseball player, but because of a research project we were doing in Rawlings Adirondack Bat Company in Dolgeville, New York. And they gave me a bat with my name on it, which was kind of neat. The long story short, because it's a real bat, it's got my name on it, it's going to last forever, at least until as long as I'm alive. And the carbon that's in this bat has been sequestered.
Right.
And it's not going to go in the air as CO2, it's in my bat.
As long as your wife doesn't throw it in the fireplace, you're okay, right?
The fireplace is not my concern with what my wife might do with the bat.
Now, again, some of these others, what can you tell us about, for instance, this looks like a hardwood of some sort?
No, actually, this is a, interestingly enough, it's a hard wood, but it's a softwood.
Softwood.
It's a softwood. It's a southern pine, which has been pressure treated with a preservative. And of course, it's been in my office, so it hasn't been exposed to the elements. But the pressure treating of this would then allow it to be used on a deck behind your home or at a dock or somewhere. And you know, it's going to last for many decades without being attacked by fungi, insects, or if it was in the water, marine organisms.
Right. Okay, now I want to skip ahead to this because this is fascinating. I hope people at home can see the texture of this, but this is what you would call an engineered product?
This is an engineered composite wood product, and it's manufactured by taking veneer, which has been peeled, and the veneer you normally think would be put into plywood. But in this case, they take the veneer, and you might be able to see the strips on here. The veneers are sliced and chopped into strips, maybe something along the lines of 8 to maybe 20 inches long, and about a half or 5/8 of an inch wide. And then adhesive is put on them, and then they're extruded into a machine and then cured with a microwave energy, such that it will come out as a timber much larger than this, maybe 8 or 10 inches wide and as deep as 20 inches. And that gives us a manufactured timber that will perform actually better than large timbers that were taken from trees in years back.
So you don't have to go after the large trees. This actually is stronger.
It's actually more uniform, and from its engineering perspective, the properties are much more predictable. And so it allows us to do things with wood that you would normally need a large tree to do. And again, if the trees aren't available and we choose not have to go after them, this is what we can use.
Terrific. And this is the kind of thing that you do in the wood products department here.
Absolutely.
Excellent. Well, we thank you very much for joining us today, Dr. Smith. It was a pleasure. We'll hope to see you again soon. When we come back, we're going to talk a little bit more about green construction. So
one of the two most commonly used tools is the hammer. Hammers are used to drive nails, brads, anchors, and assorted other fasteners into a variety of materials like wood, gypsum, wallboard, and masonry. The most common is the claw hammer. Pounding them in on one side and pulling them out on the other. The claw hammer can also be used as a pry bar. Choose a size and style that's comfortable and easy to handle. You don't want it slipping out of your hand. Ball peen hammers are used for shaping metals and closing rivets. It's not a safe substitute for driving nails. Sledgehammers are used for larger jobs, such as driving fence posts or breaking up concrete. A joiner's mallet, an all-wood hammer, usually made of beech, is used for tapping wood joints together or driving chisels. Hammers produce fine debris, so you should always wear protective clothing and safety glasses.
I'm joined now by Dr. Susan Anagnost. She's the chair of the Wood Products Engineering and Construction Management here at SUNY-ESF. Thank you very much for joining us, Susan. We want to talk now about green construction because I think there are a lot of misconceptions about what exactly that means. It really is a comprehensive plan for building anything from a home to a factory building to a school, and it really starts right at the design level. It includes the materials used and the site preparation also?
That's right. There are many facets to the process of green construction. It involves the design of the building, which is done by the architects. Then the construction managers go out and have to implement this design, and they use materials and energy efficiency, cost efficiency to develop a building that has the least environmental impact.
And all of that goes into some kind of equation that they can actually quantify, is that correct?
There are rating systems such as LEED and Green Globes that actually do try to quantify this, and those are constantly being refined and improved as more and more is learned about environmental impact of materials.
Right. Now let's just use a hypothetical if we could. If someone was building a home, let's say they're demolishing an old home, a wood frame home, what would they have to do with the old wood in order to meet some of these green construction standards?
If you can recycle steel or recycle wood, that's a very positive thing to do. Also, the materials that you put into the building, if down the road they can be recycled and used again, that goes into the equation. The cost of producing the materials in the building is definitely a factor. And when you compare the three main materials used in construction, which are wood, concrete, and steel, wood actually comes out being the cheapest to manufacture.
Well, what kind of wood is important then in green construction?
Well, wood itself is important in green construction because it's low energy produced. It's produced actually by the sun. The trees grow the wood, so it's renewable and a natural product. Also, manufacturing wood is actually consumes the least energy of the three building materials: wood, concrete, and steel.
We know, for instance, that concrete manufacturing is a big greenhouse gas emitter.
Definitely.
And steel production, we all have these iconic images of steel plants belching smoke and all that.
Right.
But wood, you don't have that.
The impact on carbon emissions is actually the least when you manufacture building materials from wood.
Okay.
Also, when you think of carbon credits, almost half, or 49% of wood is carbon. So any wood that you put in a material or into a building, it's going to stay there for a long time. So it's sequestering carbon for many, many years.
Now, of course, many people also have in their minds that it's more expensive at the outset to build green. What is the latest with regard to the costs and the remediation of those costs over time? Has that improved?
The costs have improved. It used to be thought that green construction was kind of a fad, or that it was very expensive.
Yeah.
But over time, consumers are demanding good environmental quality, and they're demanding low environmental impact, and realizing the importance of this on our environment.
Now, you might wonder, how do we know how strong wood is? How do I know I'm using the right wood for the right construction project? Well, right here in this building, they do that sort of strength testing. Take a look.
Welcome to Baker Laboratory at the SUNY College of Environmental Science and Forestry. Today we will be testing some large wooden structural members that are going to hold up the houses and buildings that we live and work and play in. The first test we're going to do is a bending test. We have a beam that's supported on two sides, and we're going to put a load on it. We're going to put the load on it over and over again to make sure that the member will retain its physical properties and do what it's supposed to do throughout its entire service in the building or what have you. Now, if we go over to the apparatus, we can watch the piece bend and see what kind of numbers we come up with. Well, here we are at the Electron general testing apparatus. What we have here is, this is the beam I was talking about. Here's a hydraulic piston that's applying the force. Above, that cylinder above is the, it's just a little device that measures how much load is being pushed up into it. What we have here are these machines collecting data, and basically what's going on is the hydraulic piston is pushing up and releasing. What this is simulating is, supposing that this beam was in service, it was, you know, in the floor or in the ceiling or in the wall, and it's being loaded again and again. So here's, here's 1,000 pounds, 1,000 pounds, and what it's supposed to do is simulate years and years and years and years of use. The next test we're going to do is a compressive strength test. This equation right here, well, basically what we do is we take the beam in this orientation and load it like this. Before we were bending it, now we're compressing. Here we are at the Young testing machine. What this machine does is pushes down, and here's our piece of lumber in here, and we're going to squeeze it and squeeze it and squeeze it. Basically what we're going to do here is push on it so it squeezes down 0.01 inches per minute, which is a hundredth of an inch per minute. And we're going to see how much force it takes to do that. So what's happening here is the machine is pushing down on that, and we're expecting somewhere greater than 120,000 pounds of pressure before we have any kind of problems with this. But it could go up as high as 250. It could go higher than that. It's really, it's an estimate. But this material that we have in here is basically aspen, different populus species. And from the Wood Handbook, we find that, that 120,000 to 250,000, those numbers make sense for this size of a member. Now this is about 50 square inches in cross section, whereas this piece is about 30 inches squared in cross section. Now this piece of material is made out of Douglas fir, as opposed to the aspen that we have in there now. Now this broke at well over 120,000 pounds, and it's much smaller than that is. And that's due to the nature of the material, and it's very important to account for these things when you're designing, when you're specifying what you want to use in your buildings and your projects.
Power drills are handy tools, but they can hurt you if you're not careful. Make sure the drill is at a proper angle for the hole you need. And don't push too hard. That makes the drill bit wear out faster. Use the right drill bit for the materials. There are drill bits designed for wood, metals, concrete, and masonry. Keep your hand away from the trigger when tightening the drill bit in place. Many fingers have been damaged this way. Even drilling wood can heat up the drill bit, so let it cool before removing it. If you like the mobility of a battery-operated drill, the better the battery, the longer it will operate. But that may mean a bigger battery that's heavier to lug around, so make sure it's fully charged before using it. And finally, always wear your safety glasses. A tiny piece of debris will feel like a boulder if it gets caught in your eye.
Well, that's it for this edition of Improve Your World with SUNY-ESF. By the way, if you'd like more information on the ESF Department of Construction Management and Wood Products, you can visit their website. It's at www.esf.edu/WPE. And that's it for this edition of Improve Your World. I'm your host, Don Torrance. We hope to see you next time.